All right, so let's take a look at these. I think they refer to them as like algebra with pizzazz. These problems are a puzzle in nature. Here we're just solving for x. So the inverse of division is multiplication. So if we multiply both sides of the equation by 8, then we'll have x. And they want us to have our calculator to round to 2 decimals, and I need to be in degrees. So on these graphing calculators, it's usually some type of screen. You can see here that it is set to round to 2 decimals, and it is in degrees. So I'm set to go, and 8 times the sine of 27, I get 3.63. The angle measure is in degrees. It's still the same, so I know that my calculator's in degrees. I know that it's fixed to 2 decimals, so all I have to do is solve for n. If I multiply both sides of this equation by 75, then that will tell me what this variable n is. 75 times the tangent of 18 degrees, I'm getting 24.37. The sine of 40 degrees, now here, I'm in degrees, I'm fixed to 2 decimals. When you cross multiply, when you have a proportion like this, a fraction equal to a fraction, most students enjoy the technique of cross multiplying. And if you do that, you have along this orange highlighted line, I have 4, and along the other, I have a times the sine of 40 degrees. Now, here, to solve for a, you divide both sides by the sine of 40 degrees. I generally skip this second step and go directly to here because I know that multiplication is commutative, that the sine of 40 degrees times a is the same thing as a times the sine of 40. If I simply switch places with this diagonal, then I have a equals 4 divided by the sine of 40 in just a single step. So I am getting that a is equal to, at least to 2 decimals, 6.22. Again, I'm going to switch places with the cosine of y, because if I place this over 1, I can think of this as a proportion. So immediately I have that y is equal to 92 divided by the cosine of 5. It only saves you one step, but it is a little bit of a time saver. I'm still in degrees. I'm fixed around to 2 decimals. You know, it's oftentimes I'll even go back and just double check that that's true, because, you know, it's embarrassing to make a mistake just because you're in the wrong setting on your calculator, or at least it is to me. So I'm getting 92.35. So the directions have changed here. They want me to round to 1 decimal. And at least this problem is in degrees. So with I have two, well, every triangle has 3 sides. This, with respect to this 35 degrees, this is the adjacent side. And they're not asking me anything about the adjacent side, nor are they providing any information about it. The only thing that they're doing is asking me to calculate the length of the opposite side with respect to this 35 degrees, and they give me the hypotenuse. So of my, well, 3 of the 6 trig functions, the SOHCAHTOA is a phrase that helps us remember 3 of the 6 ratios for a right triangle. And if I'm not using the adjacent side, then I'm going to pick the sine, at least initially, to see if this works, and it should. The sine of 35 degrees is equal to the length of the opposite side, this ratio of x over 12. So now to solve for x, multiply both sides of the equation by 12. And that'll tell us what x is. And we've got 12 times the sine of 35. And to 1 decimal, I'm getting 6.9. So with respect to the 54, the adjacent side and the hypotenuse, well, that's the cosine. So the cosine of 54 degrees is the adjacent side, which I'm trying to figure out that length, x, divided by the hypotenuse. If I multiply both sides of this equation by 30, then I have solved for x. And I have 30 times the cosine of 54, 17.6, at least to 1 decimal. Oh, and that has units of meters. Did the last one have units? It did. It had units of inches. So you should probably get in the habit of including your units. So with respect to the 22 degrees, this is the opposite side and this is the adjacent side. Because opposite the 90 degrees is always the hypotenuse, no matter which angle it is. But with respect to this 22 degree angle, the 85 is the adjacent, x is the opposite. The trig function that I have on my calculator is sine, cosine, and tangent is the opposite leg over the adjacent leg. I mean, I could do cotangent, but since I don't have a cotangent button, it's just easiest to do tangent, right? So I have x over 85. The inverse of division is multiplication. If we multiply both sides by 85, then we get a 85 times the tangent of 22, 34.3, and that has units of length of feet. With respect to the 16 degrees, the x is the opposite leg, the 4 is the hypotenuse, and opposite and hypotenuse, I'm going to use the sine. The sine of 16 degrees is equal to the opposite leg, which is x, divided by 4. Multiply both sides of the equation by 4, and we have solved for x. And at least to 1 decimal, I'm getting 1.1. And that has units of length in centimeters. With respect to the 65 degrees, this is the opposite leg and the adjacent leg, and the trig function that uses opposite and adjacent is tangent. The tangent of 65 degrees is equal to the opposite leg divided by the adjacent leg. Multiply both sides of the equation by 9. And I have solved for x. Plug that into my calculator. And I have 19.3 units of length, and it is in miles. With respect to the 51 degrees, x is the adjacent leg, The 70 is opposite the 90, so that's the hypotenuse. The trig function that uses adjacent on the adjacent hypotenuse are cosine or secant, but since I have the cosine button, I'm going to use cosine. The cosine of 51 degrees is the adjacent side, the length of the adjacent side divided by the length of the hypotenuse. Multiply both sides of the equation by 70 in order to get x by itself. .1 units of length, and that's in feet. With respect to the 36 degrees, 15 is the opposite leg, x is across the 90, it's the hypotenuse, and the sine is the trig function that sine or cosecant. But on my calculator I already have sine, cosine, and tangent buttons, so the sine of 36 degrees is 15, the length of the opposite leg divided by the length of the hypotenuse. I'm going to treat this, it's a proportion, the claim that one fraction is equal to another. If you multiply along the diagonals, then I'm just going to simply switch places. Multiplication is commutative, and I have that x is equal to 15 divided by the sine of 36. Plug that into my calculator. 25.5 units of length, and it is in meters. With respect to the 60 degrees, the 100 is the opposite leg, the x is the adjacent, because opposite the 90 is the hypotenuse. The trig functions that use opposite and adjacent are tangent and cotangent, but since I don't have a cotangent button, I'm going to use tangent, and the tangent of 60 degrees is the opposite leg, 100 divided by x, so x is equal to 100 divided by the tangent of 60, and at least to one decimal, we have 57.7 units of length, and this is in inches. There's our answer for that one. So here we have a little application problem, and they've provided us a sketch. We'll be doing application problems soon, where sometimes that may be the most challenging step for students is to picture where the right triangle is and what information in the right triangle. You have a 25-foot ladder, so the dashed line there is representing the ladder. It's leaned against a wall, so you can see this is representing a building, and this is the wall. It makes 72 degrees angle with the ground. So you do assume that you don't have the leaning tower of Pisa, that the building and the ground are square, that you have a right angle there. You want this 25-foot ladder at 72 degrees, how high up on the building will it reach? Well, in a right triangle, the hypotenuse is always along the side, so we know that it's greater than 0 and less than 25, but we can use our trig ratios to determine the side. So of our trig ratios, with this angle of 72, x is the opposite leg, 25 is the hypotenuse, and the opposite leg of the hypotenuse we'll either use sine or cosecant. Since we have a sine button, we'll use that the sine of 72 degrees is x over 25. Multiply both sides of the equation by 25, and we have x. They want us to round to one decimal. I am fixed to one decimal, and I am in degrees, so everything looks good. And if I have 25 times the sine of 72. If I just make sure that I punch in the right numbers, I'm getting 23.8. That seems reasonable. It's less than 25. So to me that seems like a reasonable answer. Alright, so we have a ship that's sailing toward a small island 800 miles away. If the ship is 2 degrees off course, how many miles will it miss the island? So this is where your boat is, and its goal is to aim directly at this island, but there's some type of a miscalculation, and you're only 2 degrees off course. But over this 800 miles, you can see that you're going to miss the island, maybe by quite a bit. We have to look and see. When you have problems like this, the 800 miles isn't long enough to really take in the curvature of the Earth. That there are times when a ship or something like that is so far away from an island that you also have to take the curvature of the Earth in mind. But we won't have to do that in this class. All right, so with respect to this 2 degrees, the x and the 800 are the opposite leg, the opposite leg and the adjacent leg of this right triangle. So let's use tangent. The tangent of 2 degrees is equal to this ratio of x divided by 800. Multiply both sides of the equation by 800. 800 times the tangent of 2, 27, you miss it by just about 28 miles, right? 27.9 miles. So just 2 degree mistake over that 800 ends up by missing the island, you know, by pretty far. And you'll see astronomers do, you know, in space, talk about, you know, very, very small deflections over extremely long distances, how that you'll miss your planet or your target or whatever you're doing in astronomy. All right, so in this last problem, we've got this cable tower. It's drawn here. Now, although that looks like a triangle, that's not the triangle of interest. There's a cable at the top of this tower that goes down and connects to the ground. It makes a 50-degree angle with the ground. And how long is this cable? So the height of the tower is 200 feet. With respect to the 50 degrees, that's the opposite leg. X is the hypotenuse, because we do assume that this tower is square with the ground, that it's not leaning to the left or to the right, or, you know, if we use the sine, we have the sine of 50 degrees is the opposite leg divided by the hypotenuse, so I can switch places with x and the sine of 50 and have 200 over the sine of 50. And at least to one decimal, what do we get? $261.1 units of length, which is in feet. So I hope that helps, and I'll talk to you later.